Welcome, ladies and gentlemen, on this exciting exploration of a hyper-connected Korea. I am delighted that we're having this edition of the Hyperloop conference in Korea this year, because I'm personally a fan. Happy to come here very often. I see Korea as a country that is always at the forefront of technology, also at the forefront of innovation and implementation of public transport, with the great metros here being the lifeblood of the cities and the KTX racing through the country. I believe that this is a good country where we can also look at development and implementation of Hyperloop. Furthermore, I saw 2 days ago that the Korean industry had a $500 million deal with exporting metro to Egypt, and a few weeks ago I was in a metro in India where I was also sitting in a South Korean metro. So it's clear that the innovation of transport is not only within the boundaries here, but is also being shared with the rest of the world, which is exactly why we're here, of course, today. There's also a reason why we already have been collaborating with Korean industry in the past. We have a strategic collaboration with POSCO International, also one of the partners here today, who's also one of our investors. So we've been working closely together already into developing not only new types of steel, but also developing the market in Asia and Korea in particular. And with Busan, we also have a link already, because I am from Rotterdam, which is one of the biggest port cities in the Netherlands, which is sort of has a sister collaboration with Busan, one of the biggest port regions here in Asia. So we already had the representatives of Busan over at our test facility and had good conversations already in the past. So happy to be here again to return the favor. So my name is Geuze. I'm one of the founders of Hardt Hyperloop. Today there's 3 key points that I want to cover with you, and that is, one, mentioning some of the key features that I think are often overlooked in Hyperloop, in addition to the high speed. Cover the progress to date of the developments that we've been involved with, and providing some insights into the roadmap going forward, also into the collaboration between the European and Korean Hyperloop ecosystems. So let's get started on the general overview. Of course, everybody knows what Hyperloop is: a low-pressure tube reducing the drag significantly, a tube isolating from the environment, so no wind, rain, snow, no leaves on the track, making it a very reliable system. This allows you to run a fully driverless system within the Hyperloop as well. The vehicles are magnetically guided and suspended, which means that you don't have any friction with the track, but it also means that you have a large air gap, which means that the infrastructure doesn't need to be as perfectly straight. And we've developed a magnetic lane switch, which allows vehicles to go from any origin to any destination. Now, 2 of the main features that I really want to focus on today are not just the speed, not just the energy efficiency, but also more going into what Hyperloop can really do on different types of skills, transport skills, but also Hyperloop's way of implementing into the environment. So let me first just give you an example of how the traditional maglev lane switch looks that is currently operational in China. And here you see that in order to make a lane switch for a traditional maglev, you need to move the entire track, because the vehicle wraps around the infrastructure and then pulls itself upwards. So because you're wrapping around the track, you need to move the entire infrastructure. We felt, as one of the first principles to develop the Hyperloop, we had to come up with something that had no moving components in the track during a lane switch, so that it really allows full network operations where vehicles can simply merge and diverge into the network. So we're using actually a very similar system as the magnetic levitation train, but instead of the tracks on the bottom and wrapping around it, we already have a tube, so we can put the tracks on top and levitate under it. And what this allows is that there's nothing blocking us from performing a lane switch. So you see on the top, you see 2 beams, which are steel beams to which we magnetically attract ourselves. And then on the sides, we have steel beams through which we magnetically guide ourselves. So for us to make a lane switch, all we have to do is either turn on our right magnets and we will pull ourselves to the right, or we turn on our left magnets and we will pull ourselves to the left. So the infrastructure is completely static. Why is this so important? This allows you to run a network like you see in the animation here, where vehicles can at a very high frequency merge and diverge from the network, creating a single, it's more like a highway. It's not like a train where the entire train has to stop everywhere along the route, but you can have vehicles that go from any origin to any destination directly with one high-speed lane where all the vehicles can travel at high speed and then diverging into the cities. Another topic that I wanted to cover is the implementation of Hyperloop and its benefits compared to other modes of transport. So, excuse me while the noise is getting worse and worse, but this is a train that is coming through the tunnel, traveling at very high speeds, almost going into a sonic boom. As an example, but of course I'm also a train fan. But what I wanted to illustrate here is that Hyperloop is not just a low pressure for the high speeds. What it also allows is that you can build a much smaller tunnel without building up a lot of air inside of the tube. So you already heard the air coming quite when it was still quite deep into the tube because it's building up a lot of pressure. Because we don't have any air inside the Hyperloop tube, we also don't build up this pressure, so we can build infrastructure that is much smaller around the vehicles. And also, this drastically reduces both the noise that Hyperloop produces compared to rail, but it also reduces the infrastructure size. And that means that if you have to build a tunnel, the size of the infrastructure is much smaller and also less costly to build and be able to build it with much cost-effective technologies. This is a comparison if you don't put it into tunnels, but rather implement it above ground, where Hyperloop is also using the least amount of space. And I think the best comparison is always with the road. One Hyperloop tube is exactly the same width as one highway lane. And for example, in the Netherlands, the Dutch Road Authority, of course, we're looking at widening the highways, but the project managers of one of the highway widening projects, which is currently on hold because of emissions issues, already has a poster not of a widened highway, but of a highway with a Hyperloop next to it, because we can use that same space to make a much higher capacity system, because this one Hyperloop tube provides the same capacity as those 6 lanes of road. So these things together also allow us to build Hyperloop into the spatially integrated into the environment with very little impact. So here, for example, you see it integrated into a dike. Here you see a Hyperloop with solar panels on top and with a green growth on top of it. You could go as far as building Hyperloop through buildings integrated with markets and so on. Of course, I'm going quite far here, but the main point here is because there's no noise, because there's no vibrations, it is very easy to integrate it into an urban environment. And this is my favorite, of course, as a Dutchman. You could also build a bicycle highway right on top of it to integrate it with the first and last mile solutions. Now, the combination of these two things, being able to do lane switches and also being able to integrate it very tightly into an urban environment with less impact than typical metro or rail systems, means that Hyperloop is also possible to be used in much shorter distances. So it doesn't always have to be the very long distance, very high speed solutions. You could also run, for example, a metro type of service, where a Hyperloop simply stops at every station. You can run a service, say, from Busan to Seoul, where you also have stations at Daegu, Daejeon, and Suwon, where you don't have to stop in between. You can go directly from any origin to any destination. Or you could, of course, run a higher speed tube, but it does mean that you will have less stations in between because you would have to slow down and speed up every time. So there's already quite a few places in the world now where we're negotiating with city councils to see whether Hyperloop can be either a new metro line or supplementary to existing metro lines. For example, that every 10 stops, there's also a Hyperloop station, so that you can almost wormhole to the other side of the city and then use a few metro stations as a feeder also to get to your final destination. And what we've noticed is that in the models that we've made, that usually Hyperloop doesn't compete with metro or rail. Rather, by building a Hyperloop, the entire public transport system becomes more attractive, and it even increases the ridership of rail as well as a feeder to the Hyperloop network in a competition to aviation and road transport. So let me show you quickly what we believe traveling with a Hyperloop could be like. This is a station we've developed with Schiphol Airport, the airport in Amsterdam. And as you can see, the stations can look quite a lot like metro or rail stations. The vehicles will stay inside the infrastructure, so you can exit and enter through sort of a sealed door. And inside the vehicle, of course, we cannot have any windows, so we have to play with lighting and virtual screens on top. But we've done a lot of tests with users which have indicated that this is the right type of sizing and people feel comfortable traveling in this type of infrastructure. This is a first-class type of seating. The sizing of this is exactly the same as the airplanes where you sit 2 by 2, so you can also run it like that. But there's also, it's possible to run it more like a metro where you have cram capacity and people standing, but it depends on the local circumstances and the speeds and the headways that you run there locally. Hardt has already developed several kinds of test facilities. We've built a full-scale test center that you see in the middle. It's a very short tube, only 30 meters, but it did allow us to demonstrate levitation, guidance, propulsion, and the lane switch already in a low-pressure environment. We've also built several other tests which simulate, for example, the high speed, vibration benches that stimulate as if you're going at a very high speed and then showing that we can eliminate those vibrations. For example, a wheel that spins up to a very high speed in which we can already simulate the motor. But the big next step is to build the European Hyperloop Center. This will be built in the northern province of Groningen in the Netherlands. This is a render, by the way, it's not fully constructed yet. But as you can see here, the key feature that we also want to demonstrate here is being able to do that lane switch. So you see a single tube diverging into 2 tubes, so we can showcase multi-vehicle, merging, diverging network operations. This will be an open test facility, so even though we are supplying the guideways, it will be owned by a separate foundation and will be run similar to, for example, wind tunnels, rail testing infrastructure, where everyone in the world can come and test as well. If you ask us nicely, we'll give you the specification. You can already start developing also technologies based on this, which we believe can help start becoming the basis of a global Hyperloop standard. It's currently under construction. On the top left, you see some of the tubes that are ready to be assembled. On the top right, the middle tube, you already see the tracks being assembled within it, because we believe that you can already fully assemble a Hyperloop within a factory so that you can easily build it on its columns on the location. On the bottom left, you see the lane switch being constructed out of 2 half plates and plates on the bottom, on the bottom and top. And on the bottom right, you see the foundations already being laid. We expect to have the first tubes there already in September for a small opening event, but we expect to have the real tests done somewhere halfway next year. So if we put this into a timeline, basically our history is that we won Elon Musk's Hyperloop competition back in 2015. That's when we launched Hardt as a company. We built the first full-scale tests, did the prototypes that simulate high speed, and are now building the European Hyperloop Center. From here onwards, we expect that we will need until around 2026 to really take all the learnings from the current test facilities, also take all the learnings from all the other Hyperloop companies that are performing tests, to converge towards a single new specification and do the passenger prototypes. And at the same time, we're also speaking to various knowledge institutes and universities around the world now to see if we can also build some local segments of the European Hyperloop Center to start building on that standardization. The goal is to have a first pilot up and running by 2030. This will really be something just a few kilometers long, more focusing on really demonstrating the reliability of Hyperloop, that it can function as a public transport system rather than really focusing on the very high speeds. So that from 2030 onwards, we can really start building out the longer Hyperloop routes that also demonstrate its higher speed capabilities. And over time, increasing the complexity, speed, number of vehicles, lower the pressure, and so on. Hardt is mostly a technology company, so we're about 45 people, and about 3/4 is really the engineers making the technology happen. As a part of our company, we also have some people who, for example, develop metro systems, designed the civil infrastructure for metros and trains, have made simulations for running train networks. So we also have a full suite of software that we've developed, which we can use to plan Hyperloop routes, how to integrate them to environments, doing the socioeconomic cost-benefit studies. So we're also partnering with regions, cities, and governments to help them, for example, in their master planning, look at what Hyperloop could do for their country. So here's some examples that I just ran into our software. Here's an example of sort of a north-south line from Seoul to Busan, where the travel time within the Hyperloop would be about 40 minutes, compared to, of course, a bit over 2 hours right now with the high-speed train. You could also run more like a west-east route, say from Mokpo to Pohang, also within about 47 minutes. But the great thing here is, here you see there is no direct train line between these two cities. But if you would build this west-east line and this north-south line, you can go from any origin to any destination within this network directly, and you wouldn't have to have these transfers. And that's really what the effect is of these lane switches without moving components. Now, to finish off, just a little bit of a visionary, there's these images around the web, right, of a hyper-connected world, sort of a metro on the world scale. This is, for us, what the long-term vision is. And that's why I also think it's so important that we, in the end, reach a single interoperable system, that we make standards, and that the infrastructure becomes open, and that we can then have industry competition, all the sides of stuff. How do you build the infrastructure? How do you build the vehicles? Better motor systems and levitation systems in the vehicles, and so on. This is also the reason why we open up the European Hyperloop Center, so that we can already start working on having the same infrastructure standard, and then really building out the technology from there. So I hope that with the industry that is already working on Hyperloop in Korea, we can also collaborate and converge towards that single technology, so that it can really be a technology for all. So thank you, and let's make this hyper-connected world a reality.
Thank you.